Okay, hello. So today we're going to talk about smooth muscle and its difference between skeletal muscle. So here we have the example of our smooth muscle, about the inside of the cells and how it looks. So just like everything else, here we have the ICF and here we have the ECF. This big part in here is the SER, the smooth endoplasmic reticulum. And here we have an example of our skeletal muscles. We have the SER here, we have the ICF here, and here we have the ECF. So, just like before, we can put a bunch of calcium inside the SER since that's found a lot, and a lot outside as well. So, what's the difference between these two? Well, if we start with our skeletal muscle, here we have, wait, just let me label that skeletal muscle. We have here our DHP L-type channel, and here we have the RYR channel. So when, as we talked about before, when the bong from the neuron comes and stimulates the DHP or with sodium, since it's voltage gated, it opens the RYR, which allows the calcium from here to go inside the cell and cause action potential. And that allows for power stroke to happen.
Whoa. Action potential?
Or
action potential happen?
Well, action potential is happening here.
When calcium comes out?
Yeah, when calcium comes, action potential causes calcium to come in. That allows power stroke to happen, which allows our muscles to contract. And so and then here we have the circa pump, which allows us to pump the calcium back in. And similarly, here we have a circa pump, and here we have an RYR channel. But unlike them, the DHP channel is actually out here, and it does not open up the RYR channel. Instead, we have here a G protein coupling receptor. So when the motor neuron sends the signal here to the G protein coupling receptor for a smooth muscle, that stimulates or activates this ligand here, or this enzyme called phospholipase. And this phospholipase here, phospholipase C, synthesizes something known as IP3. And this IP3 comes and opens up the RYR, allowing the calcium here to flow into the sarcoplasm and start power stroke. Now, one thing to note about the power stroke here in the smooth muscle is that it happens on a much slower rate than in skeletal muscle, where skeletal muscle is more dynamic and at the moment to get something done quickly. Smooth muscle doesn't only just take calcium from here though. We also have a mechanically gated, it's a stretch muscle channel.
Yeah.
So it allows calcium that's floating out here, out in the ECF, to come out here once it's stimulated, and that allows more calcium to come in. And with a combination of the calcium used on the outside and the inside of the cell, that allows smooth muscle to continue doing power stroke and continue doing things 24/7. An example of this is our heart. Our heart is a type of smooth muscle that uses a system very similarly to this, so that we can continue pumping our heart every moment without worrying that we're going to run out of energy or we're going to go into a paralytic moment. And so this is smooth muscle, and that's skeletal muscle.
Okay, what stimulates the G protein coupling receptor?
G protein coupling receptor is not stimulated by action potential, unlike the skeletal muscle.
That will be activated by There's a chemical ligand will bind it to G
Yeah.
protein couple receptor.
There'll be a ligand here.
And
And
bind
this-
it to.
Ligand comes and stimulates it.
Mm-hmm.
Just like how it works pretty similarly to our smell. Our smell also has different types of ligands that bind to the G protein coupling receptors.
Okay, so which one of them will be the second messenger?
Second messenger, the IP3 is as the second messenger that that also works as the intercellular messenger. Okay, thank you.